So today we're going to learn how do we actually calculate how much boiling point or freezing point changes when we add those solutes. Okay. So first we have to talk about something called molality. Everybody say molality. Okay. It looks similar to molarity, however, it is different. Okay. So when we talk about colligative properties, we're talking about that ratio of the solute to the solvent particles. And so the way we express that ratio is we use something called molality. If you want, highlight, start, underline it. It is slightly different from molarity. So we find the molality of a solution by just taking the moles of the solute divided by the kilograms of the solvent. Okay. So write down this equation. Please notice it is molality. Does this look very, very similar to molarity? Okay, so be extra careful with your letters. Okay, so moles of solvent divided by moles of solute divided by kilograms of solvent. Okay, so we're going to practice finding the molality of a solution that contains 25 grams of glucose dissolved in 200 grams of water. When we write molality, it's typically a lowercase m. Okay, so that's how we would differentiate it from molarity, which is a capital M. So we need moles of solute. In this situation, which one's the solute? Okay, the glucose. So we need moles of glucose divided by kilograms of the solvent. And what's the solvent in this one? The water. Okay, so kilograms of water. Okay, are you given moles of glucose? Okay, not directly. Are you given enough info to calculate moles of glucose? Okay, so we know we have 25 grams of glucose. How do we convert from grams to moles? Okay, molar mass. So add up C6H12O6. Is it 180-ish? 180. Okay, 180.18. Are you getting that? Okay, so then we just divide. So what's 25 divided by 180.18? It should be a tiny number. Are we getting a tiny number? 0.14? Do y'all agree? Okay, so this is our moles. So now we can plug it into the equation. So we know we have 0.14 moles. You're given 200 grams of water. How do you get from grams to kilograms? Okay, you can divide by 1,000, or how many places do you move that decimal? Okay, or move it 3. Either way, we should all get to 0.200. 0. Okay. All right, so now we just divide it. What's 0.14 divided by 0.2000? 0.7? Good. Okay, so the molality is 0.7. The unit is like a mole per kilogram. All right, this time we're going to figure out what mass of sodium chloride must be dissolved in 500 grams of water to create a 0.75 molal solution. Okay, so we're going to use our equation for molality. So molality is equal to moles per kilogram. Okay, this time what are we solving for? Okay, mass. Is mass part of that equation? Okay, but so what do you have to solve for first? Moles. Then can we get from moles to grams? Okay. So I'm just gonna plug. So my molality is 0.75. Okay. I'm gonna call moles X. And we know it's 500 grams of water. However, what unit does water have to be in? Okay, it has to be in kilograms. So 500 grams is the same as 0.500 kilograms. Okay. You with me there? Okay, so how do we solve for X? Okay, multiply these two numbers. So what's 0.75 times 0.5? Okay. And that was for moles. So we know we need 0.375 moles of sodium chloride. Do we know how to get from moles to grams? Okay, so last step, 0.375 moles of NaCl. Okay. And how do we take it to grams? What do you have to multiply it by? Okay, you got to multiply it by molar mass. Okay, so 22.99 plus 35.45. Okay, so 58.44. So then what's 0.375 times 58.44? I'm going to say 9. So 21.9 grams of NaCl. So now we're going to look at, well, how do we actually calculate, like, by how much does boiling point or freezing point change when we add, let's say, salt to boiling water? Okay. If you didn't write the equation down for boiling point change, go ahead and copy this equation down. All right, typically, what does this little triangle mean? When you see this triangle in equations, what does the triangle mean? It is sometimes heat. In this case, it isn't. What else could a triangle mean? Change. Okay. So in this context, it means change. The T stands for temperature, and the B stands for boiling. Okay. So how much does the boiling point change? Okay. KB is something called the molal boiling point constant. This value is given to you every time. It changes depending on whatever your solvent is. Okay, so this is a constant. It'll be provided to you. And then little m is molality. So you need the equation down. I have a typo. You don't have to write every single word down, but that little delta TB is the boiling point elevation. KB is just a constant. You do need to know little m is molality. Oops. Equation is used to calculate by how much the boiling point changes, okay, or the boiling point elevation. If we want to calculate like the total boiling point of the solution, it's just the boiling point of the pure solvent plus that boiling point elevation. Okay. We do problems where we calculate either or. Okay, so we just have to pay attention to wording. But if it's water, what's the boiling point of just water? In Celsius, what temp does water boil in? Good. Okay, I think almost all the time ours is just going to be in water. So whatever your boiling point elevation is, you just add it to 100 degrees, and then that's your new boiling point. Does that make sense? Okay, we're going to calculate the boiling point of a solution of 1.5 moles of glucose and 500 grams of water, and then the Kb value for water is 0.512. So to calculate the change in boiling, it's just that Kb times m. Okay. So this is the equation we're using. Kb is the constant, so that number is always given to you. Okay, so Kb is 0.512. And then what does little m stand for? Okay, molality. Okay, so molality is moles of the solute, so 1.5, over kilograms of water. How many kilograms of water is this in? Okay, 0.5. So let's calculate molality off to the side. So what's 1.5 divided by 0.5? Robert, I think you said it. Okay, just 3. Okay, so we're going to just put 3 into the equation down here. So what's 0.512 times 3? Okay. If Kb is in degrees Celsius, this one is in degrees Celsius. Okay. So that means by adding 1.5 moles of glucose to 500 grams of water, you increase the boiling point by 1.5 degrees Celsius. Okay. Now this one's asking for the boiling point. So boiling point, we're just going to take the normal boiling point of water, which is, and we're just adding it to that change in the boiling point. Okay. So what's the new boiling point of water? Good. Okay, so that new boiling point is 101.536. And does that make sense? Like think about like when you add a solute into like your cooking, like you add salt into boiling water, you don't get like this ginormous change where your water is like way hotter, right? Like you just increase it a little bit. So does that make sense? Like we're not expecting like a huge difference, just a small difference. For freezing point depression, this one you probably don't have to write as much down. Okay. For freezing point, it's still delta TF. Okay, so the change in the temperature of the freezing point. Okay. KF is just the molal freezing point constant. Okay. Again, this number gets provided to you every single time. And what do you think little m means? Okay, still molality. So for this one, you might be okay just copying down the equation. Okay. Right, do you see how this one is almost identical? Okay, so you probably don't have to list everything below it. And if we want to calculate the freezing point of the solution, we just take the freezing point of the pure solvent and now we subtract it by the change in that freezing point, or the freezing point depression. What is the freezing point of water in Celsius?
0.
Okay, 0. Okay. I think almost every time I give you the freezing point of water. Okay, we're going to do one practice problem for freezing point. So we're going to calculate the freezing point of a solution of 2 moles of sucrose and 500 grams of water. The KF value for water is 1.86. So we're just going to use our equation. So the change in our freezing point is equal to Kf times little m. Okay, Kf is provided to you. So this time it's 1.86. Okay. And what does little m stand for? Okay, molality, I'm just going to calculate it off to the side. So we have 2 moles of sucrose and how much water? Okay, 0.5 kilograms. What's 2 divided by 0.5? Okay, 4. So we take 1.86 times 4. Okay, what are we getting? 7.44. Thank you. Okay, so by adding that much sucrose, we're going to lower the freezing point by 7.44 degrees Celsius. So now we're going to actually calculate the freezing point. Water, like plain old water's freezing point is, 0 degrees Celsius. Then we have to subtract the 7.44. Okay. So then this solution freezes at negative 7.44 degrees Celsius.